This diagram shows a light inelastic string passing over a smooth pulley B. So we have A mass 2m. I'm going to call that 2 in this question. Second smooth pulley C of mass m. I'm going to call that 1. And D and E of mass m and 2m, so 1 and a 2. I'll leave out the m's in this question. We'll just say m is equal to 1. It'll allow us to do that. So what directions have we got here? We have 4 for pulley C, including the weight of C. So A is going to go up with acceleration A, small a. So C is going to come down with acceleration small a. E is going to go down with acceleration B and down with acceleration A. So for E we have A plus B. And D, if E is going down, is going to go up with acceleration B and down with acceleration A. So its acceleration is going to be B minus A. So let's look at some diagrams here. Starting with A. We have my string, we'll call it T1. And we call the other one T2. I have mg. A, we said it was 2, so 2g, and acceleration in this direction. So we're going to get T1 for A, T1 minus 2g is equal to ma 2a. Let's look at C. With one string going up, 2 going down. C's weight is going down, or its mass is going down, times gravity, mass times gravity. C is 1, so we just have 1g. So my equations for C are going down, 2t2 plus g minus t1 going up equals ma. C is 1, so just equals 1a or a. For D, we have one string, which is T2. We have a mass of 1, so 1g, or just g, and we have its acceleration we have gotten already as b minus a. So D is going up to begin with, so T2 minus g is equal to ma, or just 1a, m was 1. And for E, we have one string, T2, E is 2, so mg is 2g. We have E going down with an acceleration of b plus a, or a plus b. So for E, we have 2g minus T2 is equal to m, which is 2, times a, which is a plus b. And over here, why did I just write a here? It's times m, which is 1. I'll put the 1 in, times a, which is b minus a over here. So what can we do here? We can get rid of the T2s between the last two. We can get rid of T2s between the top two. So look, there's so many ways to do this. It's the order of so many things. Why don't we get rid of T1 in the top two? So if I write this equation over beside C, I get plus T1 minus 2g. Just double check, yep, equals 2a. So I'm going to get 2t2 minus g is equal to 3a. So next I can get rid of T2. I can write T1 is equal to 2a plus 2g if I need to use T1 to substitute. Where can I see that happening? If I do that in here, well, not there, let's move on. Let's get rid of T2 on the last two. Then we can get rid of T2 here. That might be enough actually, I think, in this question. So I have T2 minus g is equal to b minus a, and I have this guy 2g minus T2 is equal to 2a plus 2b. Be careful when we don't have them lined up, maybe just put an arrow between them. So we're going to get 2g minus g is equal to 2a minus a, and b plus 2b is 3b. So we have g, a and b, we have T2, g and a, so we do need to replace this T2 with something, or use this equation with another T2, so we can put it in. If I multiply this one by 2, I'm going to get 4g minus 2t2 is equal to 4 times a plus b. And if I write this one down underneath, I can write minus g plus 2t2 is equal to 3a. So I'm going to get 3g is equal to 7a plus 4b. And I can multiply this one by 7, or minus 7, minus 7g is equal to minus 7a minus 21b, minus 7 minus 21, so we're going to get rid of our 7a's. 3g is equal to 7a plus 4b. You can see they're both going to be minuses, so we're going to get minus 4g. 4g is equal to minus 17b, or 17b. So b is equal to 17. No, b is not equal to 17. b is equal to 4g over 17 meters per second squared. And we have an equation for a here. A is equal to g minus 3b. A is equal to g minus 3b. A is equal to a full g, they're over 17. 17g over 17 minus 3 times 4g over 17 is just going to be 17 minus 12, or 5g over 17 meters per second squared.